This is looking at problems 3 and 4 on the group study session. Problem 3, we have to rewrite this quadratic function in standard and vertex form. Vertex form looks like this, where h and k, the vertex is at h, k. Well, how do we do that? It says we use complete the square. So down here, let's rewrite this function. F of x is equal to x squared minus 6x plus 5. Notice completing the square, we've talked about solving equations, Khan Academy solving equations, and you notice you isolate when we're solving an equation, setting this equal to 0. This is, we isolate this 5 onto the other side of the equation. If we're rewriting a function in vertex form, we still isolate the 5, but we will keep it on the same side because we're not solving an equation. We're just rewriting this right-hand side. So what we do, we leave ourselves some space over here to put the completed square, and I'm going to put that other space there, and then plus 5. I hope we got the right color. So the completed square, notice up here there's an a here. Well, this is more complicated if a is not 1. In this case it is 1. And you can kind of assume that you will not have to deal with leading coefficients that aren't 1. It adds some complexity, but it's not horrible. And we have this plus 5 out here. Okay, so remember what we did. We bring down, well, we just have x. Half of negative 6 is negative 3. And then we're going to square that negative 3. This comes down here as negative 3. And then we square this. That's plus 9. So we add 9. Let me try another color, like Sal does. Plus 3. Now, this added 3 here. We need to balance that. Minus 3 out here. My bad. When we square 3, we get plus 9. Plus 9, and then we balance that with minus 9 out here. That way we've added 0. We haven't changed what's on the right-hand side. We've just added 0. But it will change the form. Now x squared minus 6x plus 9 is the perfect square. It's x minus 3 squared is this. This whole thing here, let's get rid of this. Just erase that. Try that again. Okay, so all of that together is minus 4. And we have our function now in vertex form. And notice it's x minus h, so h is equal to 3. K, it's a plus k, so that stays the same. K is equal to negative 4. So our answer is 3 minus 4. You could graph this. And you would be able to verify that that's where the vertex is located. Okay, let's quickly move over here to quadratic formula. This is the quadratic formula. It's let's go with this color. quadratic formula. You may want this for your notes. Option B, if you're going to bring notes to the test, is plus or minus the square root of b squared minus 4ac all over 2a. So in this problem, a is equal to 1, b is equal to negative 4, c is equal to negative 6. Now, simplified radical form, we're going to have to simplify, you might assume we have to simplify a radical in this case. Well, let's just plug in values. The opposite of b is the opposite of negative 4 plus or minus square root of negative 4, this negative 4 squared. Just know that whenever you square this b, it's always got to be positive. Don't be tempted to put negative 16 there. Minus 4 times 1 times negative 6. All over 2a, or all over 2 times 1. Now, let's simplify this. This is going to be equal. That's what x is equal to. So x is equal to, let's change color here a little bit, 4 plus or minus the square root, let's just do this in our heads, negative 4 squared is 16. Now we've got a minus times a minus, so this is going to be plus. 4 times 6 is 24 times 1, so plus 24 all over 2 times 1 here. That, let's just erase this a little bit here. That is going to be 4 plus or minus the square root of 40 all over 2. Now, in order to see if we can simplify this, we could certainly, we have to be able to divide the 2 into both of these terms in order to really simplify. So the question is, this radical 40 simplify? Well, we'll just come up here and simplify 40. I do a prime factorization, that's 2 times 20. This is 2 times 10, 2 times 5. I have a pair of 2's, so that's a perfect square that I can bring out on the outside. It's really, perfect square is 4, but when I bring it out, it's 2. And what's left is radical 10. 2 times 5 is 10. So this is now equal to 4. Sorry about that. Apologies here. This is 4 plus or minus 2 radical 10 over 2, and these coefficients out in front that don't have the radicals can be simplified. So 4 divided by 2 is 2 plus or minus square root of 10. These are our zeros. 2 plus or minus square root of 10. Simplified radical. And we're done.